Welcome back, Pirates. In this unit so far, we've been working with solving equations. The first two lessons, we talked about the structure of an equation and the operations that are happening to the variable and how we work backwards doing addition or subtraction, then multiplication or division to solve that equation. So we're going to continue with that idea today about solving an equation. We're going to go back into, for some of you, what you would consider the traditional way to solve an equation. So you're going to like this. But our focus today isn't about just getting an answer. Our focus is going to be about learning the reasons why we do the things we do to solve an equation, what properties allow us to do that. So it's a lot more explanation than it is about just getting an answer. Okay. In your do now that you just worked on, I asked you to solve these ones traditionally. So many of you would have added 5 to both sides in order to solve for x. You would have probably crossed this out or said, oh, it just canceled. You would have ended up with 22. Then maybe you go, well, there's multiplication, so I'm just going to divide here. That'll cancel. Then I'm going to do it over here, and I end up with x is equal to 11. And there you have it. And probably at this point in your life or in your, your educational career, I think that many of us would have said, well, the reason that I added here was because I wanted them to cancel out. But we don't really know why they cancel or what made us add. Or do we know why we did it on the other side? I think a basic idea might be, well, because I did it on the one side, I have to do it on the other. But do we really know why we did that? That's what we want to focus our attention on today. The reasons why we're doing what we're doing when we go to solve equations. Now, in order to help us with some of those explanations, we are going to use some of the properties that we previously learned and add a few more properties today. One of those properties that we're going to look at today is the property of equality. And that's the property that has us do two things to both sides of the equation. Now, there's something called the additive property of equality, and there's something called the multiplicative property of equality. And let me show it on a real simple scale. Here's a real simple equation. 8 equals 8. Totally true. Now, what the additive property of equality says is if I add something to one side or subtract something, it goes for both. If I was to just do it to one side, it wouldn't stay equal. The only way to keep this equation equal would be to then go ahead and do it on the other side as well. That's the addition property of equality. So when we go to solve this equation here, the reason why I add 12 to the other side is the reason that we see right over here, so that we can keep the equation balanced. So let's apply that same idea to what they call the multiplicative property of equality. And that says the same thing. It just goes for multiplication or division. Let's show it with division. If I was to divide by 2 here, I would get 4. And if I didn't do it on the other side, I'd end up with 4 equals 8. And that's not a true equation. The only way to keep this equation true is to do whatever I did on the other side to this side as well. And that's the reason why when we're going and solving equations, whatever you do on one side, we do on the other. That's to keep the equation true, to keep it balanced, okay, to keep it equal. Hence the name, the property of equality. Now, there is another property that's happening over here in this problem as we go to work on it. It's actually the first thing that you looked at there. This part where I added 12. And why did I add 12 to negative 12? Basic idea is that it cancels out, but what we have there is what we call the additive inverse. We're doing the opposite operation, or what we call the inverse operation. Inverse means opposite in math. And it's not just that it cancels. Really what happens is negative 12 plus 12 is 0. So yes, typically we do this, but really what's happening is we get 0. And 4x plus 0 is just 4x. So we don't typically write that 0. Now, I will then here, since it's multiplication going on, most people realize I divide by 4. That is called the multiplicative inverse. Now, yes, I know I'm dividing, but we still call it multiplicative inverse. And that is saying that when I do the opposite operation here, it doesn't just cancel, it becomes 1, but 1 times x is just x. So we don't typically show that 1 there, we just put x. Now, multiplication property of equality says I should divide this on the other side. 30 divided by 4 gives me 7.5. So, a lot happening just to get to an answer of 7.5. Let's highlight all these different things. So first, we had the multiplicative inverse. That was the first thing that happened. That's where negative 12 plus 12 sort of canceled out. Then we had the addition property of equality. And let me use a different color for that. Let's highlight these all in a different color. Then we had the addition property of equality. That said that whatever I do on one side, I have to add or subtract to the other to keep it balanced. Then after that, we had our multiplicative inverse, which is what we see right here. That's how we canceled out the 4. We did the opposite operation. Think of it that way. And then finally, we had our multiplication property of equality, which had us multiply or divide on the other side to keep it balanced. So I color-coded all those things so you can see all the different properties, all the different explanations that actually went into solving that equation. Okay, the expectation is that today we can talk about the reasons that these equations are solved the way they are, not just get an answer of 7.5. So I'm going to leave this up on the screen just for a second. You can always go back, rewatch the video, and pause it and color code your own notes, because I can for sure tell you that there'll be times where I'm going to ask you all these properties. In fact, part of your assessment this year will be, can you explain all the steps needed in solving an equation, not just solve an equation. That's more of a 7th grade thing or an 8th grade thing. Being able to explain what you're doing, that's where it becomes this algebra part of it. Okay, so for our first example that we'll do together, let's take a look at this one. You notice I see a property there that we've done previously, the distributive property. So we always want to handle that first. If there's distributing happening in the problem, make sure you take care of that first. So 4 times 2x is 8x. 4 times negative 5 is negative 20. And if this problem said, hey, list all of your properties, I would say the first thing I did was the distributive property. All right, now we're going to add 20. So let's pause for a second. Why did I add 20? That's called the additive inverse. Okay, I'm going to abbreviate here, but that canceled out the negative 20, or it made them 0. 8x is equal to, well, I'm going to add 20 on the other side. Pause for a second. What's the reason? Addition property of equality. I apologize, my handwriting there is not super great, and I am abbreviating, but the addition property of equality. 12 plus 20 is 32. Okay, there's multiplication here. So the multiplicative inverse of multiplication is division. So I divide by 8. And think about it. Yes, it cancels, but it becomes 1. 1 times x is just x. Multiplication property of equality says that I should, that says multiplication property of equality says that I should divide by 8 on the other side, and when I do, I end up with x is equal to 4. But I put little notes there just to let you know all the things that I just did there to solve for x. That's our goal for today. Again, can we explain all the steps needed and all the properties used when solving an equation? All right, one more together. That's going to look at another property that we've done. Take a look at the following example. Okay, I see definitely the distributive property, but I also see something else going to happen here in a second too. 6 times 10 is 60. 6 times negative 3x is negative 18x. But look at here. I also have another x in the problem. This is that property that we talked about in the last unit. where we might want to group them together and associate them so that we can combine them. I'll just allow you at this point, because we're out of that unit, to go ahead and just combine like terms. The fact that those things are alike means that we can simplify them. So that becomes 60 minus 2x equals 78. If you need a calculator, go ahead and use it. Negative 18x plus 16x is negative 2x. That reason is just simplify. That's what I did there. Now, at this point, this is a positive 60. Even though it's not written there, that's a positive 60. So I'm going to subtract 60. It's the additive inverse. Whatever I do on one side, I do on the other. Addition property of equality. That gives me 8x. Here, I still have a negative 2x. Don't lose track of that negative. I'm going to divide by negative 2. That's the multiplicative inverse. I'll divide by negative 2 over here to keep it balanced. And I'll end up with x is equal to negative 9. There you have it. All the steps needed to help us solve that equation. Okay, we're done with the classwork, or the practice problems together. But before you get into the classwork, I actually want to show you the first question in your classwork, because I just want to remind you that when you look at this problem here, that's not a 2 that's being distributed. That is a negative 2. So just be very careful about that. Sometimes you see that, and I just want you to realize it's a negative 2 you're going to distribute. All right. Well, good luck when you go to try these on your own, and we'll see you next time.